All right, geometry children. Yesterday, we talked about triangle congruence using SAS. And today I'm going to give you another pair of ways to find out if triangles are congruent, and that would be using angle side angle or angle angle side. Now, just like yesterday, when I said the order mattered, the angle had to be included in between the two sides. The order matters here too. Angle side angle means the side is included between the two angles. So let's start off by taking a look at what an included side would look like. So let me draw generic triangle here, which we'll call XYZ. And yesterday, whenever we talked about included angles, we said an angle was where the included angle was where the two sides meet. This is an included side, meaning it is the side that connects two angles, or that it's between two given angles. So when we're talking about an included side, they are between two given angles. For example, side XY is included between this is audience participation time, is included between yes, Ellie is giving me the three-letter way to name the angles, and she did it perfectly. And Emily is giving me the lazy way to name the angles, which is angle X and angle Y, which is weird. I'm used to Ellie giving me the quick and easy answer and Emily giving me the overly complicated one. You've switched today. The reason that I don't have to use all three letters when naming these angles is because if I say angle X, there's only one angle that could be. I need to use the three letters when angle X has two angles coming off of it. Side XZ is included between God bless you, my child. Is included between X and Z. Hey, I'm noticing a pattern here. I'm noticing a relationship between the names of the sides and the angles that the side is included between. It's probably just a coincidence. Side ZY is included between angle Z and angle Y. Oh my goodness. What a coincidence. I did not see that coming, except I did. So the reason we need to know the included side is so we can use the first of our two theorems that we're going to learn today, which is the angle side angle congruence theorem. And although it would be really fun to write the phrase angle side angle congruence theorem every single time I did this, I think perhaps we will abbreviate it as ASA. I cannot stress this to you enough. The order matters. ASA means the side is included between the two angles. So what does the angle side angle or SA congruence theorem say? It says if two angles and the included side of one triangle God bless you, my child. Of one angle, not one angle, one triangle. There's no such thing as the included side of one angle. The included side of one triangle are congruent. Should it be are congruent or is if two angles on the included side of the triangle are congruent, not is congruent, are congruent. Okay, now you're just doing it for attention. I'm gonna have to ask you to stop sneezing because people are trying to learn. So two angles on the included side of another triangle. Then those triangles are congruent. As with most things in math, I feel like the theorem becomes much more clear with a picture. So I will not draw one because I prefer it when you are confused. All right, fine, you talked me into it, I'll draw a picture. I will use a ruler so that you do not make fun of me, so that you don't make fun of me for this. We'll call this one triangle ABC. And next to it, we'll put a triangle in a different orientation, just to keep things interesting. That's as interesting as we get in this class. Two triangles, but they're pointed in different directions. I don't want to blow your mind. Two triangles in fair Verona, both alike in angles and side measurements. Angle A and angle D, we're going to make congruent. Angle B and angle E, we're going to make congruent. I'm drawing the diddly-doos on here to prove that they're congruent, although I think you can tell by drawing that clearly they are exactly the same. And the included side, which would be side AB and side ED, those are going to be congruent as well. This is enough information for me to prove, using the angle side angle theorem, that triangle ABC is congruent to triangle, and the order matters. A was congruent to D, B was congruent to E, so then F has to be the last one, by the angle side angle congruence theorem, or ASA if you're lazy. And I strongly encourage you to be lazy. Yes. You've raised my hopes and dashed them most expertly. They're having a funeral in a restaurant? Oh. There won't be a body? Seems like a violation of health code or something if you did. So that's ASA congruence. The other one that we're going to learn is angle-angle side congruence. And that is when you have two angles and the non-included side. So basically what I'm saying here is, if you have two angles and a side, you can prove that the triangles are congruent no matter where the side is, but you have to know which of the two theorems is appropriate, the one where it's the included side or the one where it's a non-included side. So this says, if two angles and a non-included side of one triangle are congruent. To two angles and a non-included side. Of another triangle. Then the triangles are congruent. And as usual, I will illustrate this point with my normal flawless drawings. Then I will send a message to Mrs. Taylor and give her the bad news. Ellie has ruined what little chance of happiness we had today. Don't try to save it. My day is ruined. My disappointment is immeasurable. That is so selfish of them to pass on a day when I wanted a sandwich. Some people just only think about themselves. Some people are so self-involved thinking about themselves instead of me. So we're going to make angle A congruent to angle D. Angle B, we're going to make congruent to angle E. And a non-included side, let's say AC, is going to be congruent to DF, which is enough information for me to prove that triangle ABC is congruent to triangle. Order matters. A is congruent to D, B is congruent to E, and F is all that's left by AAS. Oh, good. She didn't text me back. She's going to read the first message and get excited, and then immediately read the second message and have her hopes dashed. So these are two different ways, two new ways that we can prove triangles are congruent. And speaking of proving things, there we go. One person is faking happiness. I appreciate it. You can say no all you want. I know the truth. You love it. You say hate it, but I think what you really mean is love. Well, how about this? You have to do proofs, so why not have a positive attitude about it? On the angles and the prove, yes. How dare you criticize? You people just aren't happy unless you're criticizing me. That sounds like a non-apology. You apologized for my handwriting? That's a non-apology. I'm sorry that your handwriting's terrible. That's not an apology. I don't think it sounded like she tried. That just hurts my feelings. I mean, like if I had feelings, they would be hurt right now. Okay, so let's go ahead and mark the given information. I was given that KN and ML are parallel, so let's put the diddly doos. And I was given that angle K is congruent to angle M. Now, anytime you see a shape like this and you're told two lines are parallel, you should immediately be thinking to yourself, Mr. Taylor is so handsome. I bet he works out. And then the second thing you should be thinking to yourself is, I bet this is going to be one of those alternate interior, alternate exterior, one of those kind of things. Usually when you're told two lines are parallel, it's because something like that's coming down the pipe. Well, I'll go ahead and do the first step for you. It's the hardest. KN is parallel to ML, and angle K is congruent to angle M. I'll go ahead and do the hard one for you. You're welcome. Given. All right, I'm ready to be dazzled and amazed by your transversal knowledge. How do we know that? Yes, but what's the reason? Okay, so we can say that LN is congruent to NL because of the reflexive property, everybody's favorite property. Why did I have to reverse the order? Why couldn't I say LN is congruent to LN? Right, but why is that bad? Maybe, but also look at the order in which the proof statement is written. The prove, the first one is L first and N last, and the second one is N first and L last, because it's reflected. Exactly. That's why you can't just say LN is congruent to LN. Okay? Okay, I was expecting you to do the angles on step 3, but that's okay. Now that we're on step 3, we need an angle, right? Yep. Angle MLN is congruent to angle KNL. How do you know, Ellie? Good. Alternate interior angles theorem. You know what? I think each one of those triangles has two congruent angles and a congruent side. So it's definitely going to be one of the two theorems that we learned today. What a coincidence. So we can prove that triangle LKN is congruent to triangle NML. And the only question is it angle side angle or is it angle angle side? Meaning the side that we were given, is it the included side or not? Yes, because side LN is not in between the two congruent angles we were given. So it's not the included side. That would be angle angle side. Angle angle side is also where Dorothy went, to the land of Oz. Hey. Haters gonna hate. You don't have to feel bad that my jokes are so funny and yours aren't. Not everybody's destined for comedy. You can learn it a little bit, but like you can't become a master unless you're born with it, like we are. I know. It hurts when you're like, I'm never going to get to that level of comedy genius. But hey, listen, you cannot use me and Ellie as your metric for success because then you're constantly going to fall short. You can't pick like the two funniest people in the world and compare yourself to them. You need a more realistic standard. Dane Cook. Shoot for that. All right. So there's our given and our proof. Let me draw you a picture. I'm going to draw you a pretty picture. So I can start off in my proof by doing the given information. Angle T is congruent to angle U. And S, yes, S is the midpoint of TU. So let's see, angle T and angle U are congruent. Can do that. S is the midpoint. Feels like the kind of thing that we could use in our second statement. I don't know that we can say anything useful with that yet, but I bet it's coming. TSR and VSU are congruent because, very good. So step number 2, we could say angle TSR and angle USV are vertical angles. Because of the definition of vertical angles. And as Ellie pointed out, if they are vertical angles, that means they are congruent. So our next step can be that angle TSR is congruent to angle USV because vertical angles are congruent. I don't know that it's strictly necessary to have that second step in there. We left it out yesterday, and I felt kind of bad about leaving it out yesterday because I feel like maybe we need it, maybe not. I don't know if you need to define that they're vertical angles first before you say they're congruent, but you know what? We'll play it safe. All right, so that's pretty good. We got 2 angles. We just need a side. How do we know? Very good. Because S is the midpoint of TU, we know side TU is congruent to side, it would have to be US. Oh, yeah. You are correct. And the reason is definition of midpoint. So congruent. Hey, we have 2 angles and a side. That's exciting. So triangle. Hi. UBS. What's the reason? So close. ASA. And